Hello and welcome back to Higher Maths Trigonometric Expressions, the wave function. So we're just going to have a look at another example here. So express 4 cos x plus 3 sin x in the form r sine bracket x minus alpha, where r is greater than 0 and alpha is between 0 and 360. So again, 4 cos x plus 3 sin x, and let's have a quick look at what that looks like. So that gives a beautiful smooth sine or cosine wave. So that is a sine wave. Remember, this normally starts at 0, so it's either been moved 53 degrees to the left, or what might have happened, it might have moved 306.87 degrees to the right. The thing about if we start here and just drag everything back, we are going to get another smooth sine wave. And we have an amplitude of 5 rather than an amplitude of 1. So it's essentially been stretched up, it's been stretched a bit vertically and moved horizontally again. So let's have a look at how we'd find out those values. So same as last time, we expand this, so use our formula sheet, multiply through by r. So it was k last time, but it's r this time, but it's exactly the same method, guys. Again, here, rather than writing r sine x cos alpha, I've decided to put the cos alpha before the sine x. So when I'm comparing sine x terms here, on the right-hand side of the equal sign, I have r cos alpha times sine x. On the left-hand side, I have 3 times sine x. So r cos alpha will equal 3. And for the cos x terms, minus r sine alpha equals 4. So make sure that we do notice the sign here, because we have to have the same coefficient of cos x, the same amount of cos x's on each side of the equal sign. So that will give r sine alpha equals negative 4 when we multiply both sides of this equation by negative 1 to find out what r sine alpha is. We don't want negative r sine alpha, we want r sine alpha, which would be negative 4. Now again, these angles have got to be correct. Sometimes when you guys are just learning this and you've not quite mastered it, I'm seeing r sine x's creeping in here, you'll be losing a mark for that. Same here, if you don't expand your bracket, you'll be losing a mark there as well. Next step, find the value of r. R is just the value of r cos alpha squared plus r sine alpha squared, so 3 squared plus negative 4 squared, which is 25, square rooted is 5. And then find the value of alpha, so consider tan alpha, which is r sine alpha over r cos alpha, so negative 4/3. So find the inverse tan of 4/3, which is 53.1 degrees. So we're just doing a cast diagram question here, really. Now, are we looking in the fourth or the second quadrant? Because in both of these quadrants, tan is negative. Well, we do know that r cos alpha is 3. So that means that cos alpha is positive. So the answer must be in the third or the fourth quadrant. We also know r sine alpha is negative. Oh, sorry, r cos alpha is positive. So alpha must be in the first or the fourth quadrant. R sine alpha is negative. So it can't be in the first or the second. So alpha must be in the third or the fourth. So we're basically picking a quadrant where it has to be in the first or the fourth. It must also be in the third or the fourth. So that means it's got to be in the fourth one. It can't be in the first one because that's not in the third or the fourth. So it must be in the fourth one. So alpha would be 360 minus the 53.1, because in the fourth quadrant we do 360 minus the angle. So our value of r is 5, our value of alpha is 306.9, and then rewrite it in the form r sine x minus alpha as we were asked to do in the question. And that gives us 5 sine x minus 306.9 degrees. Let's have a quick look back at the video. So it was 5 sine x minus 306.9. So it does have an amplitude of 5, and it has shifted 306.9 degrees to the right. So that works out really well. So we've got the diagram of what that would actually look like. Oh. Yep, there it is.